Okay, so this is Dr. Lennon, and we are going to look at a problem similar to uh, problem number 4 on the final, where we talk about a capital budgeting problem with 5 projects represented by binary variables, and you want to just write a constraint by hand modeling each situation. So I've got a pretty similar problem here, just with one fewer project. So we basically have a constraint modeling each of the following projects, which we call A, B, C, and D. And we'll also call those our binary variables. And we have 3 questions. At least 3 of the projects must be undertaken. Project 1 or 4 must be undertaken, but not both. And project 3 cannot be undertaken unless projects 1 and 2 are already undertaken. Okay, so first, just a quick rehash. The idea of a binary variable is very simple. It can only take on 2 values, 1 or 0. So let's, again, a binary variable can only take 2 values, 1 or 0. So, that corresponds to on or off. These things are actually used quite a bit by computer programmers in their implementation of truth table schemes at the actual hardware electronic circuit level, using things like logic gates. So these have a vast array of applications. But basically what we want to do is just take each of our situations and see if we can write equations to model it. So the first question says at least 3 of the projects must be undertaken. So again, what we're going to do is we're just going to say let A, B, C, and D be binary variables. And that's all that means, is they can only be 0 or 1. No other number. And again, we're just basically calling this project 1. This one, project 2, and so on. C, project 3, and D, project 4. So for the first one, at least 3 of them need to be done, and it doesn't matter which 3, so that's all we need to do is basically add them together, and if we do 3 projects, the sum total will be 3 or 4 if we do at least that many. So we just need to say if we add them all together, it's greater than or equal to 3. So basically, for each variable, if it's a 1, that means the project's undertaken. So A can be 2 things. If it's 1, that means if the project is undertaken, project 1 is undertaken. And it will be a 0 if project 1 is not undertaken. So we can come back to question 1, and that's what it said. At least 3 of the projects must be undertaken. So we might just make a note if we really want to. So note 1 is undertaken, and 0 is not. But you don't need to. That's pretty much the standard default way to do it. But our actual equation will just be A plus B plus C plus D is greater than or equal to 3. And that is the constraint that represents at least 3 of the projects must be undertaken. Question 2 is interesting. Project 1 or 4, so our binary variables A or D must be undertaken, but not both. So if they were both undertaken, then what would that mean? That would mean that they would both be a value of 1. So we want that not to be the case. So we just need one of them to be undertaken. So we kind of have 2 things that have to happen first. Basically, A or D has to be, those are our binary variables, so one of them has to be undertaken but not both. So what if we just did A plus D has to equal 1? What are the only possible ways that could happen? That could basically only happen if A is 1 and D is 0, or D is 1 and A is 0. So that's exactly what we want, right? Because there's only two possibilities. A equals 1, D equals 0, or A equals 0 and D equals 1, right? A plus D can never, cannot both be 1, because if you would have 1 plus 1, that would give 2. So with our binary variables here, A plus D equals 1 will give us exactly the situation we want. Project 1 or 4 must be undertaken, but not both. Notice you can't have 0, 0, because if you would add those together, that would equal 0. So that would be our constraint model for question 2. Finally, question 3. Project 3 cannot be undertaken unless projects 1 and 2 are already undertaken. So this one we can do with just some inequalities. So how can we do this one? Okay, so let's think about this. Project 3 cannot be undertaken. So project 3 cannot be turned onto 1 until 1 is done and 2 is done. So basically C has to be less than or equal to A, and we also have to have the equation C has to be less than or equal to B. Why is that the case? Well, the only possibilities that we want to satisfy, so what are the possibilities where this works is basically we could have project 1 undertaken and 2 not undertaken. So, right, let's just think about basically the possibilities. We could have a chart where we have A, comma B, and then we also have the third variable C. So if we write this chart, and it's basically just telling us the state of each project, whether it's been undertaken or not. So basically there's 3 scenarios that we want to consider. A is undertaken and B is not. A is not undertaken and B is undertaken. Or the case where A and B are both undertaken. And in each case, so if A is undertaken and B is not undertaken, then C has to be 0, because C cannot be undertaken until they both are. And in this equation, 0 and 1, C also cannot be undertaken because A is yet to be undertaken. And in this final position, C could be 2 things, right? C could be 0 or 1, because project 3 cannot be undertaken unless projects 1 and 2 are already undertaken. So notice, basically C has to be less than A, and C also has to be less than B in all of these scenarios. The only way where C can be 1 as well is when A and B are both equal to 1. And if you would try and envisage any possibility where C is undertaken before A and B, it would look like A and B would have to be the pair 0, 0, and you would have to have the pair C equal to 1, which would not satisfy our constraint up here. So that would not work out for us. So that basically tells us that this is one way to write the constraint model using binary variables, just those 2 inequalities. C is less than or equal to A and C is less than or equal to B. There are also other ways you can do it, but I've tried to do each one of these where we're basically just using inequality signs in addition and not multiplying anything. And there are some advanced features in Excel, but this is just a useful thing to see because linear programming is actually a big background tool for a lot of advanced computer science type applications. Okay, so this is a slightly simpler version. Your question on the final just has one more project 5, and you'll just add one more binary variable, E, to represent project 5, 1 if it's undertaken, 0 if it's off. So Good luck on your binary variable question.